Hey guys, this is Ashwin, Devrel at Kernel Labs, and today we are going to learn about Kernel Studio. So, before learning or going through Kernel Studio, let's understand why do we need it. Let's take a step back. Okay, so if you have gone through our architecture, which I believe you do, so we have something called kernel node, right? So I'll try to explain it in the most simplest term. Kernel node is the heart of kernel protocol. So what kernel node does is it orchestrates the communication flow between your dApp and let's say a Web2 server or Web3 functions across different EVM chains, right? So the thing is, how does the kernel node know like what steps to execute, which target contract to execute, like how does it do the version control stuff like that, right? So of course, like kernel node is just an orchestration layer. It's not storing anything. It doesn't have any information about these things, right? So how do we let the kernel node know, or how do we direct the kernel node to do certain tasks for us? So for that, we need something called DSL. So how does that work? So let's say you want your dApp is sending a request to the kernel node through its RPC, right? So along with the RPC, you pass something called DSL or kernel DSL, which is basically in the most layman term, kernel node is basically a JSON file which contains the basic information about the workflow, like the workflow name, workflow version, stuff like that. And at the same time, it contains the steps to execute, also like what steps to execute. Let's say step one, execute this API. Step two, call this Web3 function from this smart contract, stuff like that. So once it completes execution, the last and final part in the DSL would be which target contract to hit, like all these stuffs. So let me just show you how a DSL would look like. So a DSL would look like something like this. Let me uh just give me a second. Let me show you how does that look. Okay. Let's go to some JSON formatter. Uh, Let me paste it here. Cool. So as you can see, this is how JSON would look like. Not so pretty, right? I mean, I won't be too happy if I see something like this, and someone would ask me, if I like to work on something like this manually. Of course, this is not something really easy, or at least, to maintain the structure, it sounds too hard, right? You have to make sure the JSON formatting is right. You have to make sure, the inputs are, referenced correctly, stuff like this. Okay. So, for this, to solve this problem of creating a DSL, we have created something called Kernel Studio for you. So I hope now it's clear that what Kernel Studio is, right? So now let me help you understand how to use Kernel Studio, right? So for that, first of all, we have this doc section which covers the basic about Kernel Studio, and we have like a quick walkthrough which will help up set up your first workflow DSL on Kernel Studio and help you to export it, right? So you can follow this, but let me also walk you through some of its features and how to use it. Okay. So first thing first, you have two options. When you go to the Kernel Studio, you have two options right away, right? So the first option is to create a new project. So that is like just spinning up a blank canvas and trying and just create everything from scratch. Okay. The second option you have is import project. So what does that mean is you can so whenever you create a project, you can also export it as JSON, right? And the best thing about Kernel Studio is it's storing nothing to I mean, it's not sending anything to a server or something like that. Everything is stored in your local browser. So nothing is being exported, right? So that makes sure your DSL or whatever workflows you design is private to you. I'm okay. So let's say you want to use or you want to manage your workflow in some other system, because since it's locally stored, you need to make sure that you export the JSON, and in your new machine you can just import it and start working on it right away. Okay. So let's go ahead and let's say, I mean, for now, since I don't have any project, what I do is I'll just go ahead and create a project. Okay. So you have few options. So first thing I'll do is let's name it. How about we just follow this through, and so that you will understand how to use it, right? So let's name our workflow real estate investment analyzer. Okay. So the context to this workflow is basically it goes through and it just runs few steps where it goes and fetches some real estate price, some investment analysis and all, and then executes a real estate contract based on that, right? So the first thing is we have to paste the project. Now, the second thing we need to do is select the blockchain network. Currently, since kernel is in a testnet phase, we only support Sepolia testnet, but soon we will support all the EVM chains. So currently, we just want to limit the number of networks so that we could test how the protocol works in general, right? Okay, so select the blockchain network. Currently, only Sepolia testnet is available, so it's already selected. Next thing we need to do is paste the target contract. So paste the target contract. I mean, you can go ahead and just follow this tutorial and deploy your own. Since I already have one, I'll just go ahead and use that. Okay, let me just use that. Okay, yeah. Yep, I have one here. So I've pasted it here. Next thing I would do is fetch the contract API. Okay, so why we are fetching the contract API? Anytime you are integrating kernel to your dApp, you need to make some I would say like you need to add a modifier to your function signature, basically to make sure so kernel orchestration also comes the output of a kernel orchestration is a signature per plus the result, right? So we have to change the interface by adding one modifier to the target contracts function which you want to execute through kernel node to check the signature. That's all you need to do, right? So that's why we are fetching the ABI, so that we know that which function to be targeted, right? In the DSL. So that you don't have to go and find the function from your ABI, paste it here. That's a lot of work, right? We want to make sure that it's pretty simple for you guys. So we'll just go ahead and fetch from the Explorer. There you go. So I mean, let's go back and see what we need to select, right? So, what I'll do is once it's fetched, I'll go ahead and just select this one. Okay, submit um submit property analysis. Okay, I'll just go ahead and select this one. So I'll create a project based on this. Cool. Now we have like a basic structure. You can see the canvas, right? So the canvas autofills some of the informations for you based on based on the project creation steps, right? So first thing it does autofill for you is the basic info. So as you can see, the name is autofilled. We have some intent configuration, which is basically like whenever you submit or call the kernel workflow, you also submit intent or intent signature with it. So just to make sure there is no replay attack on all. Okay. Then we have some addresses and all. Basically, these are dynamic in nature, so we'll just replace it in the front end. Okay, so yeah, I mean, also you can see, I mean, there are some places where we are using this. Now, this is like a placeholder. So so as you know, there are two parts to the kernel node, executor and attester. So simply kernel node will execute something, I mean, get some result, attested, get some result attested. So make sure every step is signed, right? Now, during these process, it can also resolve the secrets with the actual value. So that is also one of the properties of a tester, right? So I mean, if you're using something like, let's say, um paid RPC URL, you don't want your RPC URL to be leaked in public, right? Whenever you're sending the request to the as a developer, you don't want your user to know which paid, yeah, RPC URL you're using, right? So that's why we have, you can mask it using like a placeholder like this, where this will be resolved to the actual value. Because while creating that tester, you will also set the value of RPC URL, right? So yeah, I mean, that's how basically this thing works. Okay. Yeah, that's all about the basic info. Now, DApp configuration. Now this is nothing but I would say this is the target function signature you're going to hit once the orchestration is done. So it's like you execute step 1, step 2, step 3, and after that you basically hit this function signature on this target contract on this target chain, right? That's what it is all about. Next thing you can see is the workflows. Now, this is a core business. Like this is your core business logic, which you want, which you need to make sure that this is something you are spending your most time on, rather than spending time on the rest of the steps, right? So let's go ahead and try to add some steps, right? Okay. So I mean, I won't be following everything from here because that's a lot of work. Rather, I would, what I'll do is give you a brief so that you guys can go through it and follow along, right? So I'll just cover some of it and then you can follow along. Okay. So first I'll add the first step. So I mean, let's go back and follow through. So as you can see, it is asking you to add a property data fetcher step. So for that, you need to click on add node, drag and drop the HTTP get request, and basically you want to change the name, right? So let's go back to our kernel studio. So we clicked on add node. Let me just start again. Add node, HTTP request. So we are sending a get HTTP request, right? So we will just drag and drop it here. So as soon as I dragged and drop it here, you can see a new node appeared. Of course, we'll talk about it, but not now. I don't want to confuse you right now. Okay. So as you can see, we have a new node, and when you click on, so when you hover over it, you get you get the option for the step editor. I would say this is a step editor which will allow you to configure this particular step, right? So every step has their independent configuration, right? So let's go ahead and configure this one. So the first thing is step name, right? So I'll just copy this one and then I'll just paste it here. Okay. Next thing I'll do is just okay, next thing we need to do is in the setting page, there is a section called inputs. Under this, configure your API request. So this is a URL, right? I'll just copy this and I'll paste it here. Okay. So that's done. You don't need to change anything else, right? Of course, the URL is a string, so you don't need to change it anything else, right? This is just for the input box to do the validation, right? You don't, this is not very important. Like this is not the part of the DSL, to be honest, right? This is just for the input validation, right? So, so we have pasted the URL. The next thing we need to do is method is get. It's already set. We don't need to do anything. The header is, I mean, there are no particular headers, so we can just leave it as it is. Then we can move on to the output part, right? So for the output part, you can see it says set the outputs like this, right? So let's go back. So just delete this one because we don't need this, right? Click on add output. And the first thing we will do is copy this, paste it here. Again, we won't change the type, okay? Because we won't change the type. Next thing we need to do is copy this one, which is basically referencing the output value from the API. So it's basically like saying the output will be like in a JSON structure where response dot body dot search result dot set PID is the value, right? So we are referencing the exact value and we are mapping it to this one. So whenever we reference this in the in the workflows, in any part of the workflow, we can basically reference this value to this name, right? That's what we are doing. It's a basic mapping. Okay. Again, leave this as it is to export. Okay, let's add one more output, which is address dot street, copy, paste. Again, we can leave it as string. Next, the value is copy, paste. Again, we don't need to do anything. It's a simple mapping, name to value. That's all. Okay. So let's go ahead and add the next one, which is address dot city, copy, paste, and let's copy the value. Let me just do it quickly for you guys. Paste. So as you can see, like this is pretty easy, right? You don't really have to worry about like the JSON structure and all. You can just go ahead and copy paste it, right? I mean, if I would get something like this, I would be pretty excited because I don't really have to do a lot of manual work because a lot of things are abstracted because of Kernel Studio, right? So I mean, this is the last value. Let me just quickly do it. Okay. So yeah, that's it. We have configured our first step in the workflow, right? Cool. We are done with adding our first step to the DSL workflow. As you can see, we're done with adding it, but now we can move to the next step, which is constructing the EVM. Of course, like there are so many other steps to add to the workflow, but just for the sake of the demo, I'll be adding one. I'll be just adding one step, and you can follow through the tutorial and add the rest, but I'll just move forward to the next step, which is constructing avian, right? This step is really important and this can be a bit tricky. So let's first understand why do we even need it in the first place, right? So, okay, this is let's understand this with the diagram, right? So like we already learned that we hit the kernel node with the RPC request with a DSL to basically let the kernel node know on what steps to execute, what the basic workflow information, and finally what target contract to hit once the workflow is done. I mean, just uh, take the workflow result and pass it on to the target contract, and call and execute a function on the target contract, right, with the result. So um how do we do that, right? So that's the final step, and how do we exactly do it? So once the kernel node is done with the workflow execution and stuff like that, it goes ahead and call and execute a function on the target contract, which is set by you, right? Now, what is the catch here? Of course, like when the kernel node goes and hits, of course, like there are so many components in between. Like it's not a very direct process. So you can always scroll above and just check out this page. How does kernel protocol work? Where you learn about the intermediary components, which is enabling this orchestration from the RPC to the target contract via the kernel node, right? So okay, so let's understand how does this work. So this is your smart contract, and let's say your smart contract is expecting a struct. Now, I would, explain you why, like, why do we need a struct and stuff like that. So let's call it a response. Okay, let's call it response. Let's say there is field A, which is a string. Then there is field B, which let's say is a uint 256. Okay, I just want to keep it simple for the sake of the demo. So yeah, this let's say this is a response expected by the kernel node. Um, okay, I'm in the target smart contract. Okay, so how does this work? Whenever you complete execution or like execution in the kernel node, you get two results, or I would say two byproduct. One is the result, second is a signature. Okay, so and every output of the kernel node would be in ABI encoded. So when it hits the smart contract, you need to decode it to compute on the result, right? So for that, first thing you need to make sure is you know the structure which is being sent to the smart contract, right? So let's say the smart contract is so let's backing reverse engineer it. Okay, reverse engineer a bit. So let's say the smart contract is expecting this structure, right? So rather than kernel node sending any structure and letting the smart contract figure out what structure to expect and stuff, that won't work, right? Because the ABI decoding would require the exact struct in the exact order or the exact field order to for it to decode, right? So let's say let so how the kernel node will work here is it will basically pass the output as expected by the smart contract. Okay, so let's say it is expecting in this format. So now when we specify the EVM construct part of the DSL, we will basically specify the DSL to respond in this particular order mapped to the result of the workflow. Okay, let me just go back to kernel studio and show you how to do it. Okay, so as you can see, we workflow is added here, and we have this construct tbm node which I've already mentioned. I'll talk about it later in the stage. So let's go ahead and edit it. Okay, so we don't really have to change the name or anything like that. It would be pretty simple. So if we go back to the doc, it is asking us to first configure a few parameters, which is expected response in the contract or the target contract. Okay, so let's go ahead and add the fields. The first field I'll add is confidence. Again, this is specific to the tutorial we are following, but if your smart contract is expecting some other values, go ahead and add that. Okay, so confidence is UN256. So let's go ahead. Let's select UN256. Then we have expected annual yield. So just add out the field. Let's say, okay, this would be a UN256. So again, select UN256. Next one would be investment grade. Let's go ahead and add this. This would be a string. Okay. So you can just scroll down. You will find string here. Next one would be property value. Again, we will add another field. Let's check what does the data type. It's U into 56. So let's just select U into 56. The last one would be recommendation, which is a string. Okay, so let's go ahead and add this. So yeah, that's all. So basically, we have now configured the tuple structure. By that, so a tuple here would be equivalent to a struct on solidity, right? So basically, we are you can say we are just creating an empty struct here with the expected fields in alphabetical order, right? Now, we don't really have to follow alphabetical order here while adding the fields because the kernel studio will handle that for you. So when you scroll down, you will find this, which is the inputs section where you will have something like this where these fields will be automatically arranged in the alphabetical order. So you don't have to really worry about it. Okay. So let's go back to our doc. Now, the next thing we need to do is map the parameters to its expected value, right? So first we have created the structure, the expected structure. Now we need to map the expected structure to the expected values, right? Pretty simple, right? So for the confidence one, we will just go ahead and copy this, paste it here. Okay, now what is this? What is exactly this step, right? So here we are basically as you know, like we haven't added like all the steps to our workflow, but when you will add it, you will have one step called AI property analysis. Let me just show it here as well. Um, okay, so as you can see, when you will add the AI step, and you are naming it as AI property analysis, right? So when you're constructing the EVM, you have to basically reference it the value to its name dot result dot confidence. That is name dot output. Okay, pretty simple. So that's how you will reference it in the ESL. So this is the structure, like how you will do internal referencing. Like you don't really have to replace the value, replace it with the exact value. You can do a dynamic internal referencing where you can add reference internal referencing like this, where it would be name of the step dot output. Okay. So let's fill the next one, which is this copy, paste. As you can see, we all we are doing is just copy paste. So you don't really have to worry about the JSON structure or how even if the structure is correct or wrong, how to arrange these steps, stuff like this. All everything is abstracted away through KRNL Studio. So let's just copy and paste it. Okay, that's it, done. So the next step would be set outputs where it says no change needed. So that's all we have to do. And we don't really have to change this. And voila, that's it. So basically, what you've done is you have configured your first DSL workflow. Now you can basically export it, clear data, or you can add more nodes, stuff like this. So what how kernel studio helps you is it basically helps you to abstract away the concepts of maintaining the structure of the JSON, making sure if the steps are in the right order, stuff like this. All you do is fill in your I would say all you do is fill in your business logic, which are the workflow steps, right? Let's say if you are executing like a lending smart contract, and before you let anyone execute the borrow function, you add a workflow to check the credit score through the credit bureau API, right? So that is your business logic, right? You don't really have to worry about how kernel is doing it, how the DSL works and stuff like that. All you do is basically configure it in the list of steps, right? So yeah, that's all from my side. If you have any question, feel free to hit up our team on Discord. You can always reach out to me on Twitter, and our team is also available on Twitter. So make sure to try this out, and if you feel if you have any feedbacks or stuff like that, feel free to hit us up. And also, one more requirement would be, I would say, just use Chrome whenever you are using Kernel Studio, that for the best experience possible. Cool. That's all from my side. Bye bye.